Good morning, everybody. Welcome to day 2 on similar polygons. We're going to talk, just get a little practice with what we talked about yesterday. So, quick reminder, we talked about congruent polygons and similar polygons. Congruent polygons are the same size and same shape. Okay, they're identical. So if you know what a measurement is on one, you know its corresponding measurement on the other figure is the same thing. Okay, whether it's an angle or a side. Okay. Similar polygons have the same shape, but they're different sides. Okay, their sides are not, the one's bigger, one's smaller, but their sides are going to be proportional. So any corresponding size, we can use proportions to figure out what they are. Okay. All right, so we're going to start with this. Which of the following is not a characteristic of similar figures? I'm going to pause it here and have you vote A, B, C, or D, what you think, and then we'll resume. All right, welcome back. Hopefully you chose D. D is not a characteristic of similar figures. Their side lengths are not congruent. They're not the same, they're just proportional. Okay. This is a characteristic of congruent shapes, but not similar. It's the thing that's the difference between congruent and similar. The side lengths are not the same. Okay. Other than that, they are the same shape. They do have equal angle measurements, so it's kind of say the same thing. And their sides are proportional. Okay. All right, so let's look at a couple examples here, just using this information, and then you'll have a chance to practice it on your own. So here it says PQR is congruent to YWX. Okay, again, remember there's a hint here in how they're written. They're written specifically so that P corresponds to Y, Q corresponds with W, and R corresponds with X. Okay, so P corresponds to Y, so we need to flip this to there in order for them to line up. So we're kind of rotating this 180 degrees. Okay, I know they're the same size, same shape, so everything's going to be the same. That matches up. But I can match up the angles that way. I can also match up the sides the same way. Right? PQ is the first two letters. It's going to line up with YW. Okay, so PQ and YW, those are going to line up. Okay, QR is the last two letters. That's going to line up with WX. Okay, so you can kind of, if you're good at flipping it around visually, that's great. If not, this is something you can use. This is what I usually use to see what lines up with what. Okay, so if I want to know the measurement of angle X, that's how I read this, the measurement of angle X. That M there is the variable, it just stands for measurement. The measurement of angle X. Okay, well, X corresponds with R. So I know it's going to be the same as R, which is 73 degrees. Okay. If I want the side YW, well, YW matches up with PQ, okay, which is 10 yards. Okay, because they're congruent, this will also be 10 yards. They don't need to do anything with proportions when they're congruent, okay, because everything is equal. For XY, XY uses the third and the first number letters. So R, that's going to match up with RP. Okay, RP right here is 7 yards. Okay, so XY is the same. Okay, the last one gets a little tricky. Angle W right here matches up with Q, and Q is one that I don't know. Okay, so I got to use the same thing I used yesterday, which is the fact that all of the angles in a triangle add up to 180 degrees. So if I say this is, let's say, A for angle, and I want to know what it is, okay, I can think of, actually, why call it A? It's already labeled Q, so never mind. All right, so this is angle Q. So if you want to think about writing an equation for this, we know these three numbers have to add up to 180. So 61 plus 73 plus Q, I'll have to equal 180. I can even use my equation solving skills here. Okay, equation solving says to simplify by combining these like terms first. Add these together, I get 134. Okay. And then to get Q by itself, I use the inverse operation. Instead of adding 134, I subtract 134. If I do that, I get 46. So Q is 46, which means W is also 46 degrees. Okay. Let's look at one that has 4 sides and see if we can do the same thing. So if I want to know side AD, I got to figure out what that matches up with. Okay, well, AD, that's the first and last, that should match up with HG, okay, which is right here, 13 inches. Okay, so you might be able to picture, to line these up, you have to rotate this about 90 degrees clockwise, and then it should line up. If I want to find DC, those are the last 2 letters, that'll line up with GF, which is right here, 11 inches. Again, if we rotate this 90 degrees, this will be on the bottom, which will line up with DC. So DC is 11 inches. Okay, the measurement of angle G, well, G corresponds with D. I don't know that one. Let's come back to that. Angle H corresponds with A. Now, there's no number here, but there is this box. This box means it's a right angle. Okay, right angles are 90 degrees, so that's 90 degrees. Okay, now, to come back to this one, to find G, I have to know what D is. To find D, I have to use something I know about 4-sided shapes. When it was a triangle, I used the fact that all the angles add up to 180. But this isn't a triangle, so that doesn't help us here. This is, however, a quadrilateral, 4-sided shape. And one thing that's true about 4-sided shapes, they always add, the angles inside always add up to 360. Okay. To confirm that, think about a square. Right? A square has 4 right angles, right? Well, a right angle is 90 degrees, right? 90 times 4 is 360. So if we add up all of those angles, we get 360 degrees. And it turns out that that stays true for any quadrilateral, even if it's not a square. So I know 3 of the angles. Okay, let's add those up. So I got 90 is that right angle, plus 76 plus 81. That'll tell me what the 3 angles I know add up to. 7, that's 200, so 247. And then I have to figure out what the third one is to get up to 360. It means I subtract the ones I have from 360 to see what's left. If I do that, I get 113. So D is 113 degrees, which means G is also 113 degrees. Okay. All right. So one thing we did also yesterday is using proportion to find missing shapes. So this one I can kind of tell because they're facing the same way. This 14 is going to line up with the 35. This 16 is going to correspond to the 40. The 25 will correspond to this x. So if I'm going to write a proportion here, I'm going to start with what I'm trying to find, which is x, and then compare it to what it corresponds to, which is the 25. So my first ratio is x to 25. Okay, for my second ratio, I can use, because I know all the other sides, I can use this pair of sides or this pair of sides. So any other corresponding sides. Let's use the smaller numbers and do 14 and 35. Okay. So I'm going to write this because I started with the x on top. I got to start with the 14 on top here. So now I'm doing smaller shape to bigger shape. So 14 to 35. All right, so if I solve this, let's try reducing. Okay, this isn't really something we've done before, but you might notice with 14 and 35, they're both multiples of 7. So I could actually reduce this fraction, this ratio here. If I divide by 7, I get 2 on top and 5 on bottom. Okay, now if I look at this proportion, this is actually one of those easier examples where I can just think kind of equivalent fractions. Right? I have a 25 here and a 5 here. This is 5 times bigger than this. That means this x has to be 5 times bigger than that too. Right, so 2 times 5 equals 10. Right? Multiply by 5 to get to the 25. Multiply this by 5 to get to 10. Okay? So I know x would have to equal 10. Now if you didn't see that, it's fine. You could have cross multiplied, gotten 35x equals 25 times 14. You would have gotten the same thing. Okay, that's just kind of a shortcut using that proportional reasoning that we've done. Okay, so we're going to go through some examples here. I'm going to pause it, And these are all multiple choice. So you're going to have a chance to decide A, B, C, or D and vote, and we'll see how we do. Okay. So in this case, right triangle ABC is similar to XYZ. It tells me kind of what matches up with what. If the length of side AB is 15 inches, I'll label that. The length of side BC is 50 inches, I'll label that. And the length of side YZ is 10 inches. Okay, so that's right there. What is the length of side XY? So XY is right here. That's what I'm trying to find. Okay, so pause it here, see if you can figure that out, and then we'll resume. All right, hopefully you got D for your answer. 3 inches is correct. Okay, so there's a proportion I set up. X to 15 equals 10 to 50. You might have noticed this is just 5 times bigger than this, which means this 15 is 5 times bigger than this, which would make that 3. Okay. All right, let's try another one. Okay, the dimensions of the smaller rectangle are 4 by 6. What are the dimensions of the larger rectangle? Okay, so this is 2x by 2y. What do you think? All right, welcome back. Hopefully you got 8 by 12. Okay, so this is 4 by 6. This says this is just twice as big, right? This is x, this is 2x, this is y, this is 2y. So we just have to double those to get 8 by 12. Okay, and that would make those proportional because both the sides here are twice as big as the sides here. All right, so here I want to find what set of dimensions corresponds to a rectangle similar to the one above. So this rectangle is 4 to 6. Which dimensions would give you something that is similar to that? Let's pause the video here, see what you think. All right, welcome back. Hopefully you got B. B is the correct answer here. 2 to 3 is the only ratio that's proportional to this. Okay, if you think about dividing these both by 2, you get 2 to 3. Okay, if you try to reduce these other ones, this is a situation where that's probably the easiest way to tell if they're proportional. This reduces to 3/4, which is different. This reduces to 5/8, and that's 1/2. Okay, so this reduces to 2/3, so it matches up with B. All right, try this one. Okay, this one I'm not going to write down for you. I'm going to let you do it yourself. It says the two rectangles are similar. A is 8 inches, B is 13 inches, D is 26 inches. What is the length of C? All right, so pause the video here, see if you can come up with it. Okay, hopefully you got 16 inches. Okay, so B and D are proportional. It says B is 13, D is 26. So this tells me this one is twice as big as this one. Okay, so A is 8, C has to be twice as big, has to be 16. You could have written out the proportion or just use that proportional reasoning. Okay, let's try another one. Okay, it says the triangles above are similar. The length of BC is 60 feet. CA is 30 feet. What's the length? And the length of FD is 20 feet. What is the length of EF? Okay, so again, I'm going to pause it here, let you figure this one out, and vote in the chat. All right, welcome back. Hopefully you got 40 feet A as your answer. Okay. Once you label these, hopefully you can see that the short side here is going to line up with the short side here, so the ratio is 20 to 30. Okay. And then this EF we're trying to find is the biggest side. It's going to line up with the 60. So 20 to 30 equals X to 60. From there, it's not hard to see that this is twice as big on the bottom. It's got to be twice as big on the top. So 40 feet is our answer there. All right, let's try another one. So pause the video. I'm going to have you read this one yourself and see if you can do it. All right, welcome back. Hopefully you got C. 30 meters is the right answer. And once you label these, D matches up with 18. Okay, and then because I did the bigger to the smaller, I got to do bigger to the smaller, so that'll be 20 to 12 over here. Okay. Cross multiplying gives you 12d equals 360. Divided by 12 gives you 30. Again, you might have noticed this is 1.5 times as big as 12. You do the same thing here to get 30. All right, so be careful how you're setting these up. Make sure you're matching up corresponding parts and doing the same shape to the same. So the bigger to the smaller or the smaller to the bigger in both cases. Okay, if you're sticking with that, you should be fine. Let me know if you have any trouble.